Hello friends, welcome to my YouTube channel. In today's video, I will explain the topic Dynamic Programming General Method in the subject of Design and Analysis of Algorithms. Okay, first of all, what is the meaning of Dynamic Programming? Okay, it is a problem solving technique. It is one of the problem solving technique. It is similar to divide and conquer. Okay, it is similar to divide and conquer mechanism, but it stores the sub-problem solution. First of all, what is the meaning of divide and conquer rule? Divide and conquer rule means a problem is taken. Suppose a problem is there. That problem is divided into multiple sub-problems, and here sub-problem 1, sub-problem 2, sub-problem 3. Okay, here every sub-problem will get the solution, and finally all the solutions will be clubbed as the major solution. It is the technique of divide and conquer. Okay, here what is the dynamic program means? Dynamic program is similar to divide and conquer rule, but this stores the sub-problem solution. Here whatever the sub-problem solution, that will be stored in a memory location in dynamic programming. That is the difference between dynamic programming and divide and conquer. Okay, what is the dynamic programming means? It is a sub-problem solving technique. Here it is a similar to the divide and conquer rule. Here the sub-problem solution will be stored in a memory location. Okay, now see what is the dynamic programming. Dynamic programming is the problem will be divided into sub-problems, and each sub-problem solution, these sub-problem solutions are, see, these sub-problem solutions are stored in memory. Solutions are stored in memory. So what is the use of storing memory? For future references. For future references, these solutions are stored. These solutions are stored. Okay, it is one of the optimization method. And next one is dynamic programming. We use the concept of recursion. In dynamic programming, we use the concept of recursion. Here, what is the meaning of recursion? A single function defining once and call it again and again. If a single function is defined once and calling again and again. For example, if you see some function, sum of a plus b. Okay, if you declare this function, here we are declared the function sum is only one time, but we can call a plus b multiple times. Okay, same like that. It is also recursion. Okay, in dynamic programming we will use the recursion concept. Okay, here we will see the algorithm. What is the algorithm for Fibonacci? The algorithm is regarding Fibonacci series. Here I am taking in fib of n, the n value. If n less than or equals to 1, then return n value. Else return the final value is fib of n minus 2 plus fib of n minus 1. Okay, this is the major logic for Fibonacci series. What is, first of all, what is the meaning of Fibonacci series? For example, the Fibonacci series means 0, 1, 1, 2, 3, 5, 8, 13. Here, what is the solution here? The Fibonacci series is nothing but what? The first value and second value. If you add first value and second value, then we will get the next value. Again, the previous two values will be added, then next value we will get. Again, these two values are be added, then we will get this one. Again, if you add these two, we will get this one. Again, if you add these two, we will get 8. Okay, here what is the logic here? The logic is very simple. Fib of n. Okay, if n value is 0, then returns the 0 value. If n value equals to 1, then returns the 1 value. Other than these two, 0 and 1, then we will implement this logic. What is the logic here? Fib of n minus 2 plus n minus 1. For example, if I want to find out the fib of 2, so what is the value? Fib of 2 minus 2 plus fib of n minus 2 minus 1. So what is the value? 2 minus 2 means 0 plus fib of 2 minus 1 means 1. So what of fib of 1 value is 1. So what is the value? 1. Okay, we will see one live example for this Fibonacci series in this problem. Okay, now in dynamic programming, how it is possible. Okay, see here, I am taking a Fibonacci series example. Find out fib of 5. Find out fib of 5. What is the formula? Fib of n minus 2 plus n minus 1. This is the logic. Okay, here I am taking fib of n minus 2. So how we are splitting this problem? The problem is fib of 5. The problem has to divide into subproblems. What is the solution here? Based on this. Okay, here I am taking fib of 3. Here fib of 4. According to this logic, 5 minus 2 is 3, 5 minus 1, 4. Okay, again we are implement this. Okay, again we have to implement. How to implement? Fib of 1, and what about this one? Fib of 2. It is possible to divide? No, not is possible. Okay, and what about here? Fib of 2. Fib of 2 is possible to divide. So if we divide this one, we will get fib of 1, sorry, fib of 0, and here fib of 1. Okay, and what about right side? Here fib of 4, and if you divide it like this, we will get fib of 2, fib of 3. Okay, listen, how we are dividing this tree? We are dividing this tree according to this formula. Okay, fib of n minus 2 plus fib of n minus 1. Okay, again fib of 2. If you are dividing this one, we will get fib of 0, here fib of 1. And what about fib of 3? If we divide fib of 3, we will get fib of 2, fib of 1. Sorry, it is 1, it is 2. And what about 1, 2? Again it is fib of 0 and fib of 1. Okay, if you do it in general method, how many steps we are getting? See, how many functions we have to call it? First fib of 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Totally, we have to call 15 times. Okay, in general method, if you are applying to find out the Fibonacci series, you have to call 15 times fib function. Okay, in general method, in general way, I have to call 15 times fib series. Okay, if you implement dynamic programming, the calling the same function will be reduced. Okay, in dynamic programming, see, we have to store the subproblem solutions. Okay, here initially we have to take 0, 1, 2, 3, 4. Okay, initially we have to take fib values, all the fib values are 0. Okay, then see, once the problem is divided, here what is fib of 3 value? Fib of 3 value means 2. Okay, here what of fib of 1 value is 1. Fib of 0 is 0. Fib of 1 is 1. Fib of 2 is 1. Okay, now we will check. It is the fib of value. Okay, fib of 0 equals to, what is the value you are getting here? 0. So we are 0. Okay, next, after that, after this one, sorry, first we will come from fib of 0. Okay, next, what is our next value? Fib of 1. So we are taking this fib of 1. What is the fib of 1 value is? Previously the array is stored 0. So we are replacing with 1. Fib of 1 is 1. Okay, next, what about fib of 2 value? 2 value is 1. So it is also overriding with 1. Fib of 2 is also 1. Okay, next, what about this fib of 1? Already we stored. So we are not considering this value. We are not considering this function. So no need to call again fib function here. We know fib function, fib of 1 is 1. So we are already stored in the array. So no need to implement this function again. Okay, we are implementing fib of 0, fib of 1, fib of 2. And what about fib of 3 value is 2. So we are overriding fib of 3 value equals to 2. Okay, and this is the left side part is completed. Okay, here how many times were called? 1, 2, 3, 4 times were called. And what about right side part? Again here right side fib of 0, it is no need to consider, no need to call. Why? Because we know fib of 0 value is 0, and fib of 1 we no need to call. Why? Because previously we called, we know the value is 1, so it is 1. And what about fib of 0? Again we no need to call this one 0. And fib of 2, again here also fib of 2 we called here, so no need to call here. It is actually this value is 1, no need to call this function. And what about fib of 3? Again this fib of 3 also the value equals to 2, but we already previously called here fib of 3, so no need to this call this part. And what about, so this entire part will be not calling in second time. And what about fib of 0? Again this 0 we called previously, so it is also not calling. Fib of 1 value is 1, so it is also not calling. And fib of 2 value equals to 1, it is also not calling. And this entire part is not calling again. And what about fib of 4 value? The fib of 4 value is, we have to call. Okay, if you implement fib of 4, again this law of this formula, we will get fib of 4 value equals to 3. So this we are overriding this 0 with 3. And what about fib of 5 value? Fib of 5 value equals to 5. Okay, now check how many times we called the fib function here. Here we call the fib function is 1, 2, 3, 4, 5. Totally how many times? Totally 5, and this is the sixth time. So now if you are using dynamic programming, we are calling fib function only 6 times. Using dynamic programming, fib function is called only 6 times. Why? Because we stored these values in the array. We stored these fib values in the array. Okay, these values are stored in array. In dynamic programming, we are storing solutions of subproblems in the array. So it is easy. It is easy to comparing by comparing general other methods. Okay, what are the applications of dynamic programming? Dynamic programming contains the applications are, okay, the first one is optimal binary search tree. Second one is 0 by 1 knapsack problem. And next one is all pair shortest path. Traveling sales person. And last one is reliability design. These are the applications of dynamic program. In this chapter, if you discuss, we will discuss these all topics, then only our unit will be completed. Okay, if you like our videos, please subscribe, and if you have any doubts, please ask me in comment section. Thank you everyone. Hello friends, welcome to my YouTube channel. In today's video, I will explain all pair shortest path problem in the subject using dynamic programming, the subject of design and analysis of algorithms. Okay, now what is all pair of shortest path problem? Okay, here our main aim is we need to find out the shortest path between every node. Okay, every node. Okay, here we are finding the shortest path between every each and pair of vertices. For example, what is the meaning of every pair of vertices means? For example, I am giving here 1, 2, 3 is a set of values. It means 3 vertices. It means 3 vertices. Okay, it means what? We have to find out the shortest path between 1, 2, 2, 1, 2, 3, and 2, 2, 1, 2, 2, 3, and 3, 2, 1, 3, 2, 2. Okay, here every pair of vertices we are finding shortest path, and whichever taking minimum, then only we will take it. Okay, here we have to find shortest path between every pair, and whichever, okay, whichever taking minimum, we will take that. Okay, మనం ఫైండ్ అవుట్ చేసిన అన్నిట్లో కల్లా దేనికైతే తక్కువ వస్తుందో దాన్ని మనం తీసుకుంటాము. ఓకే, matrices are used to solve this problem. Here matrices are used to solve this problem. Okay, this problem will be used to by using matrices. Okay, for example, here I am taking a graph. Here I am taking a graph is example. I am taking a graph is okay. I will. Here I am taking a graph is example 0, 4, 3, 2, okay, this is the graph. Here to perform this problem, what is the rules? The rules are, okay, we have some set of rules. The first rule is no path. Okay, for example, here there is no path between 1 to 3. Okay, here a path between 3 to 1, but there is no path between 1 to 3. If there is no path, we have to consider alpha, so the value is infinity. The second path is all diagonal values, all diagonal elements I have to consider 0. And the third rule is, what is the meaning of diagonal elements? 1 to 1, 2 to 2, 3 3 3, 4 to 4. These all are zeros. And no edges. If there is no edge between anyone, then no path. Okay, no edges means no path. Okay, next, according to these rules, we are designing the graph. According to these rules, we are designing the graph by using this. Sorry, according to these rules, we are designing a matrix from this graph. Okay, see, we are calling this one as m0. Okay, this is called m0. Okay, here I am taking first element. Okay, m of 0. So this is the first one, second, 3, 4. 1, 2, 3, 4. Okay, how to take it? First one, all vertices are 0. Okay, I am taking 0, 0, 0 and 0. Next one, what is the 1, 2? What is the 1, 2 value? See here, 1, 2 value is 3. 1, 3. What is the 1, 3 value? 1, 3 value is there is no value. So we have to take no path means what? Infinity. So it is infinity. Next one, 1, 2, 4. What is the 1, 2, 4 value is? 1, 2, 4 value is 1. Okay. Sorry, 1 to 4 value is 7, not 1. Okay, 7. Okay, next one, 2 to 1. 2 to 1. What is the 2 to 1 value is? 8. Next one, 2 to 3 value. 2 to 3 value is 2. 2 to 4 value is, there is no value for from 2 to 4 directly, so we have to take infinity. And what about 3 to 1? What is the 3 to 1 value? 3 to 1 value is 5. Next one, there is no value between 3 to 2. Okay, well, the only value from 2 to 3, but there is no value from 3 to 2. So what is the value here? Infinity. And here it is vertices 0. Here also 3 to 4 is 1. So it is 1. And what about last one? 4 to 1, the value is 2. Next one, 4 to 2, there is no root, so it is the infinity. 4 to 3, there is no root, it is also infinity. And 4 to 4 is 0. Okay, now we are start building further matrices. Okay, it is m0 and we have to start building further matrices. Okay, now I am writing here. Now we have to build further matrices Okay, further matrices. Let's try to minimize the matrices. Okay, we have to minimize these matrices. Okay, we have to try to minimize these values has to. Okay, what is the further matrices means? We have to try to minimize matrices. Okay, it is M1. It is the original matrices. Okay, it is the we call this M0 is the original matrices. Next one is M1 matrices. We have to draw M1 matrices. Okay, here what the meaning of M1 matrices means? The first row, okay, first row and first column from same values from previous matrices. Okay, same values from previous matrices. Here, what is the previous value? Previous matrices is the previous matrices. So we have to take the first values from the same as from this matrices. Okay, we have to take same values. Okay, see the first row and first column 0, 3, infinity 7. And what about column 8, 5, 2? And what about the rule? All diagonal elements are 0, 0, 0, 0. And what about remaining? Here we have to fill this gap remaining elements. Okay, how to fill? Okay, how to fill? Again, we have to calculate remaining values. Okay, here how to fill means okay. Here I am taking m of 0. Okay, we have to take the previous value. So m of 0. What is the value? I will find out. This is the 1, 2, 3, 4. 1, 2, 3, 4. It is the M1 matrices. Okay, here we have to find out the 2, 2, 3. So M of 2, 2, 3. What is the value? 2 to 3 means what? We have to take M of 2 to 1 plus M of 1 to 3. Okay, don't confuse. ఇక్కడ ఇది ఎలా వచ్చింది అంటే 2 to 1, 2, 1 to 3 means how we are getting means what is the common element between 2 to 3? See in the graph 2 to 3 means 2 is the common between 1 and 3. So we have to take 2 to 1, 2 to 1, 1 to sorry 2 to 1 and 1 to 3. In between 2 and 3 the common element is 1. So we have to going 2 to 1 and 1 to 3 or 1 to 3. In between of 2 to 3 there is a common element is 1. So 2 to 1 and 1 to 3. We are reaching 2 to 3. We have to reach 2 to 3. How to reach? There is a path between 2 to 1 and 1 to 3. So 2 to 1 value is 2 to 1 value is 8 plus and what about M0? 1 to 3 value is okay. According to graph also we can consider 2 M0 of 2 to 1 value is 8 plus and 1 to 3 value 1 3 value is infinity. If you add these two, what will get? Will get 8. And what about 2 3 value of M3? M of 2 3 value is 2. Okay, by compare here 2 is less than or 8 plus infinity. Here we have to take among these two values which one will be minimum value. That value will be considered. Okay, here among these which value is less, we will consider that. By comparing here 2 and 8 infinity, which one is the less value? 2 is less value, so we are consider 2 value. So what we have to update this 2 to 3 value is 2. Okay, it is the updated value. Same like that we have to perform we have to find out all the values. Okay, after 2 to 3 what I have to find out? I have to find out the 2 to 4. What is the 2 to 4 value? M of 2 to 4. What is the 2 to 4 value equals to? What is the value? M of 2 to 4. See here, 2 to 4 value, 2 to 1, 1 to 4. So 2 to 4, sorry, 2 to 1 plus 1 to 4. What is the value, sir? Consider here. Here the left side value is 2 to 4 value is infinity. So infinity equals to infinity is greater than 2 to 1 value is what? 2 to 1 value is 8 plus here 1 to 4. 1 to 4 value is 7. So what is the value here? Infinity greater than 15. Which one is the greater value? Here we don't know infinity value, so we are taking the least value. Infinity is the more it is the almost is the maximum value, so 15 is the. By comparing here in infinity and 15, the 15 is the least value, so we are taking the 15 is the, this is the 15. Okay, and same as we have to find out m of 3 comma 2, 3 comma 4 and 4 comma 2 and 4 comma 3. Okay, see here I'm doing here m naught of 3 comma 2. The value is m naught of, how to calculate? 3 comma 2 means 3 to 2 means 3 to 1 plus m of 1 to 4. Okay, again here what is the value here? This is the m naught of 3 comma 2 means what? 3 comma 2 is infinity, and what about this value? M of 3 comma 1 means 3 comma 1 is 5 plus, and m of 1 comma 4 is 7. So what is the value here? 15. So what is the value? Infinity 15. By comparing these two, sorry, it is 1 comma 2. It is 1 comma 2. It is 1 3 comma 3. So here value is 3. So what is the value? 8. Okay. By comparing these two, what is the least value? 8 is least value. So we have to consider it is the 8. Okay, it is the 8. And what about next value? What about next value? We have to consider m of 3 comma 4. What is the 3 comma 4 means? M of, see here, 3 comma 4 means 3 comma 4. How to reach? 3 to 1, 1 to 4. So 3 to 1 plus 1 to 4. Okay, that means 3 to, actually 3 comma 4 value is what? 3 comma 4 value is in this previous value 1. So it is 1. And what about here? 3 comma 1 value is 5 and plus 1 comma 4 value is 7. So by comparing these two, it is least value. 1 is least value. So why do I have to write 1 least less than 12? By comparing these two, which one have to take? We have to take 8. So we have to fill this with you have to fill this with 1. Why? Because this is the least value. Again, next, what I have to find out? M naught of 3 comma 4 is completed. Next one, m naught of 4 comma 2. 4 comma 2, that equals to what? M naught of, see here in the graph, 4 comma 2. 4 comma 2. 4 comma 2 means I have to reach 4 comma 1 and 1 to 2. So 4 comma 1 plus m naught of 1 comma 2. Okay, now we have to check what is the m naught of 4 comma 2. 4 comma 2 value is infinity. Okay, next 4 comma 1 value is 2. 4 comma 1 value is 2, and 1 comma 2 value is 3. So it is 3. By comparing these two, infinity is greater than 5. Here what is the least value? The least value is 5. So we have to take, this is the 5 and this value as the 5. Next one, m naught of, I have to find out 4 comma 3. We have to find out 4 comma 3. So what is the value? M naught of 4 comma 3 means what? According to the graph, 4 comma 3 means 4 comma 3. So we have to reach 4 to 1, 1 to 3. So m naught of 4 to 1, m naught of 1 to 3. Okay, next. What is the 4 comma 3 value? 4 comma 3 value is infinity. So it is infinity. 4 comma 1 value is 2. 1 comma 3 value is 1 comma 3 value is 1 2 3 value is infinity. It is infinity. Okay, 4 comma 1 value is what? 4 comma 1 value is 2 and it is infinity. So by comparing here, what is the value here? Left side also infinity, right side also infinity. We are taking the infinity, so it is infinity. Okay, now check here. How many infinities in the previous value? In previously the infinities are 1, 2, 3, 4, 5. Now 1, 2. Okay, the values are minimized or not? Yes, and the values are minimized. So after that we have to same way we have to write M2 matrix, M3 matrix, M4 matrix. Okay, same way we have to write M2, M3, M4 matrices. Okay, now what is M4 matrix is the final answer. Here M4 is the our final answer. Okay, after M1 matrices, how to write M2 matrices? Okay, see here, M2 matrices, vertex 2. Okay, what is the M2 matrices? The conditions are, rules are, what is the rule? Second row, second column from previous matrices. Here don't confuse. Previous matrix means M1 is the previous matrices, not M0. Okay, when we are building M1, we have to take M0. When we are building M2, we have to take M1 is the previous matrices. So what is the previous matrices values? M second row and second column, 0, 1, 2, 3, 4. 1, 2, 3, 4. What is the values we are taking? This 8, 0, 2, 15, second row, and second column is 3, 0, 8, 5. And what about the rules? The rules are all diagonal elements are 0. So it is 0, it is also 0, it is also 0. Now the remaining elements we have to find out. Remaining elements what I have to find out? We have to find out 1, 2, 3 we have to find out, and 1, 2, 4 we have to find out. Tarvata next 3, 2, 1 we have to find out, and 3, 2, 4 we have to find out, and as well as 4, 1 I have to find out, and 4, 3 I have to find out for M2 matrices. Okay, if you find these values, what you will get? See here, M naught of 1 comma 3. It means we are finding this first one, this value 1, 2, 3. If you are finding this value, we will get that equals to what? What have to write? M naught of 1 to 2 plus M naught of 2 to 3. What is the value? 1 to 2 value is infinity, and 2 to 3 value is 1 to 3 value is infinity. And what about left side? 1 to 2 value is 3 plus 2. Okay, if we are comparing less than and 5, which one is the least value? Here infinity is greater than to 5. So 5, we have to consider 5. So here the value is 5. Here the value is 5. And the same like that, we have to write M naught of 1 comma 4 value. What is the 1 comma 4 value? If you perform the calculation, we will get 7 less than 18. So what is the least value? 7 is least value. So 7. And what about 3 comma 1 value? The 3 comma 1 value is 3 comma 2 plus 2 comma 1. So what is the value? 5. The final value is 5. Here also 5. I am not doing entire calculation. I am directly writing my answer. 3 comma 4. If you calculate, what is the value? 3 comma 324 plus 224. Okay, so what is the value here? The value is 1. The least value is 1. Okay, I am not writing consider complete answers. Please check it. And what about next one? 4 comma 1. So for 4 comma 1 means what is the value you are getting here? You have to travel 4 to 2 plus 2 to 1. So what is the value? The value is 2. And 4 comma 3, that equals to what? 4 comma 2 plus 2 comma 3. So what is the value? Here the least value is 7. Okay, so we have to fill these values. We have to fill this is M2 values. Okay, here 7, 5, 7, sorry, 5, 5, 1, and what about here? 2, and here the last one is 7. Okay, now we build M2 matrices. Okay, now we have to build M3 matrices. Okay, now we have to build M3 vertex of third node. Okay, what is the third node value? Third row, third column, same as previous matrices. Okay, here what is the meaning of previous matrices? Previous matrices means M2. Okay, if you build M3 matrices, what is the value we are getting here? M third row and third column. What is the third row values? 8. See, here what is the third row values? We have third row values are 5, 8, 0, 1. So we have to write 5, 8, 0, 1, and third column 5, 2, 0, 7. So 5, 2, 0, 7. And what is the rule? All vertices 0. Okay, if there is no path, that is infinity. Okay, now we have to find out 1, 2, 3, 4. 1, 2, 3, 4. Now we have to find out 1, 2, 2. Okay, I have to find out 1, 2, 2 value. Next 1, 2, 4 value. Next 2, 2, 1 value. 2, 2, 4 value. And last one is 4 to 1 value, 4 to 2 value. We have to find out these all the values, and we have to fill these values in the matrices. Okay, 1 to 2 value. What is the value? 1 to 2 value. Travel 1 to 3 plus 3 to 2. Okay, if you perform, the value is 3. Next one 1 to 3 plus 1 to 4. The value is, final answer is 6. Okay, I'm writing directly. You people, you can calculate in exam also. You have to calculate the final complete answer. And 2 to 1. So 2 to 1. Sorry, here 2 to 1 means what I have to do? 2 to 1. 2 to 3. Okay, 2 to 3 plus 3 to 1. So what is the final answer here? 7. And 2 to 4. 2 to 4 means 2 to 3 plus 3 to 4. So what is the final answer here? And the final answer is 3. 4 to 1. 4 comma 3 plus 3 comma 1. So what is the final answer here? 7. Okay. If you are perfect, calculate 4 comma 2 means 4 comma 3 plus 3 comma 2. So what is the final answer here? 5. Accordingly, if you fill these values, 3, 6, 7, 3, 7, 5. Okay, now where we know what is the M3 matrices. Same like that, we have to build M4 matrices. M4 matrices. What is the meaning of M4 matrices? M4 matrices means what? 4th row, 4th column. Same from previous value. 4th row and 4th column. Okay, some previous value. So what is the 4th row here? The 4th row is 2, 5, 7, 0. And what about 4th column values is 3, 6, 3, 1. Okay, check here. 4th row and 4th column are same. And what about remaining values? You have to find out. Remaining values you have to find out. 1 to 2, 1 to 3, 2 to 1, 2 2 3 and what is the vertices are zeros, and 3 2 1 3 2 2. These are the values you have to calculate. Okay, if we calculate these values directly, here I am for time being I am calculating directly. It is 3, it is 5, it is 5, it is 2, it is 3, it is 6. So I am writing here directly. So what is the values? Finally you are getting 3 5, here 5 2, here 3 6, and here it is the 3, and what about the last one? 5 7. Okay, now we know we got the M4 matrices. Here the M4 matrices is the final, M4 matrix is the final answer. Okay, if you compare between M0 and M4, the values are minimized. The first value here M, here see here the maximum value is infinity. In the M4 matrices there is no infinity values, so the values are minimized. Okay, this is the general method. Okay, here the calculating between two vertices. Okay, if you see here the calculating between two vertices, how I am calculating means, here I am taking m of 2 comma 3. That means according to the graph 2 comma 3, 2 2 3 means what is the common element, common vertices between 2 and 2? What is the common? 2 కి 3 కి కామన్ గా ఉన్నది ఏంటి? 1 కాబట్టి మనం ఏం చేస్తున్నాము, 2 to 3 కి రావడం కోసం 2 నుంచి 1 కి వెళ్ళి 1 to 3 కి వస్తున్నాము. ఇది గుర్తుపెట్టుకోండి. ఓకే, సేమ్ హియర్ 2 to 3 మీన్స్ 2 to 1 అంటే 2 to 1 ప్లస్ 1 to 3. ఓకే, ఇది ఇస్ ద మనకు కామన్ గా మనం చెప్పే కొండ గుర్తుగా చెప్పుకోవాలంటే. ఓకే, అకార్డింగ్ టు ఫార్ములా దే హ్యావ్ ఏ ఫార్ములా ఈస్, the formula is general formula. Okay, we can, if we are not using the formula also, we can find out the answers. Okay, ela we cheppinattu. Okay, what is the formula here? A of k I comma j that equals to minimum of A of k minus 1 I comma j A of k minus 1 I comma k plus A of k minus 1 k comma j. Okay, this is the general formula. Okay, we will see one value. Okay, here suppose M4 value we have to find out 2 to 3. What is the M4 of 2 to 3 is 2. Okay, we have to get answer 2. Okay, see here, it is the I value, it is the j value, and it is the k value. Okay, minimum of M4, M4, M3 means what? M3 ante actually M3 means A ante K means 4. So M3 of I comma J means what is the value of 2 comma 3? Same like M of A place lo M raskondi. M ante 3 of I value ante what is the value of 2? K value is 4 plus M3 of 4 comma K value is 4, so 3, J value is 3, so 3, 4 comma 3. If you calculate this value, we will get again 2. Okay, draw the graph cost reduced, compare original graph. Okay, now, okay, this is about the general method in the all pair of shortest path. Okay, see here, this is the one of the important topic. Okay, if you have any doubts, please ask me in comment section. Thank you everyone. Please subscribe our YouTube channel. Hello everyone, welcome to my YouTube channel. In today's class, I will explain 0 by 1 knapsack problem using dynamic programming. Okay, coming to our topic, what is the knapsack problem? Okay, first of all, it is the optimal solution. It provides the, if you perform this 0 by knapsack problem, it gives optimal solution. Okay, next one, it is the one of the application of dynamic programming. In last class we seen what is the dynamic programming, what is the applications of the dynamic programming. Okay, it is one of the 0 by 1 is also one of the dynamic programming application. First of all, what is meaning of dynamic programming? Dynamic programming is nothing but a problem will be divided into multiple subproblems, and each subproblem will be gets the solution, and here the subproblem solution will be stored in the memory location for future references, Okay, this concept is called dynamic programming. This concept is called dynamic programming. Here it is follows the dynamic programming approach. What is the approach means? Just now I explained. It is a we have to take the problem, we have to see sequence of subproblems. By searching the solution we find best one. Okay, same here also. For example, what is the problem here? The problem is knapsack problem. What is meaning of knapsack? Generally a knapsack is nothing but it is a bag. A knapsack is nothing but is a bag. Here what is the problem? Here we have to fill the bag with number of items. We have to fill the bag with number of items. Okay, here generally every bag contains some capacity value. Okay, same as here also we have to fill the bag with items, but these items should contains more value. These items should be contains more value and less weight. Okay, we have to fill our bag with more value items with less weights. Like that we have to fill number of items. Okay, the capacity not exceeds the bag capacity. The bag capacity not exceeds the bag capacity. For example, I will explain the knapsack problem. When suppose we are purchasing the products in the supermarket, or purchasing the products in supermarket. Okay, assume your capacity is 30 kgs. We have to purchase your householding things. Okay, you have to purchase all the householding requirements products. Okay, when you are entering to the market, initially you will purchase a rice bag of 25 kgs. No, why? Because if you are purchase the 25 kgs bag means there is remaining space is very less. So we have to purchase remaining required elements, remaining required items first, and later we will purchase. Okay, this is the one of the example. And suppose if you see one more example, a thief snatching gold items in a gold shop. Okay, a thief enters into a gold shop. What has to snatch the ornaments first? He has to snatch the items which contains more value, and less weight. Okay, then only he will get the more profit. Okay, suppose he will snatch the less value and more weights, it means he will get less profit. Okay, suppose if he fill the bag with more than the capacity, then after coming outside the gold jewelry shop, he can't run fastly. Okay, he can't run fastly. His capacity is 40 kgs. If he snatch the gold ornaments is 60 or 70 or 80 means it is more weight, so he can't run fastly. Okay, it is also one of the problems. So what is the knapsack problem means? We have to fill the bag with less weight and more value. Okay, the items and these items are indivisible. Okay, in knapsack problem items are indivisible. What meaning of indivisible means? You can't break an item. Either we have to take an incomplete item or not. Okay, have to take complete item or not. Have to take complete item or not considering the item. Okay, first of all, what is meaning of 0 by 1? 0 by 1 is nothing but, okay, 0 means not considering. The item is not considering. Okay, 1 means considering. Okay, suppose if you consider any item, that item equals to 1. Okay, for example, x is the item means x equals to 1 means we are considering. X equals to 0 means we are not considering the item. Okay, we will see one example for this knapsack problem. What is the example here? Here I am taking example values are here I am taking number of items n equals to 4, total weights is 5, and if the weight is 5 means the capacity of total maximum capacity is 5. Okay, and how many objects, how many items? 4 items means item 1 weight, item 2 weight, item 3 weight, item 4 weight, and as well as the values, value of 1, okay, this is the weights, this is the values, okay, values v1, v2, v3, v4. Okay, what is the item 1 value? 2, 3, 4, 5. Okay, and what about the values? 3, 4, 5, 6. Okay, by using we have n4 objects and maximum weight is 5, and these are the weights and these are the values. Okay, now knapsack bag we have to fill these items with more value and less weight. Okay, we will see example here. Let us calculate for the weights who have to get the optimal solution. That means that has maximum weights can handle items inside the knapsack bag. Okay, this is the equation for knapsack problem, and this will be the problem will be represented in this table format, matrix format. Okay, here how many objects we have? How objects are 4 objects. So n equals to 4, and these are the I value, these are the weights. Okay, these are the weights, these are the values. Here we have to take n equals to 4 items, and here I have to taking the weights. Okay, how many weights we have to take? We have to take totally 5 weights. Okay, weights are 4 items, 5 weights means we are taking here total weight W equals to 5. We consider W equals to 5. W equals to 5 means the total maximum capacity weight is 5. So we have to take 5. Okay, here if the objects are 0th object is all the weights are 0 and all the weights is 0. Okay, for 0th row and 0th matrix we have to fill with all the zeros. Okay, and what about remaining? If you take here, what about this value? First row and first column. So we have to take t of 1 comma 1, t of 1 comma 1. Okay, here we have to take, we have to calculate this t of 1 comma 1. What is the formula here? T of I comma j. Here I value equals to 1, j value equals to 1. We have to implement this value. Okay, to find out t of 1 comma 1, first of all, in this, according to the formula, what we required? We required I value equals to what? I value equals to 1, j value equals to 1. According to this formula, I value equals to 1, j value equals to 1, and see the formula here. We required value of I. So, what is the value of I? Value of I equals to, okay, value of I equals to, what is the I value here? Here value of I equals to what? What is I value equals to 1? So, value of 1, that equals to what? Value of 1 equals to, okay, what is the input data? In input data, what is the value of 1? In value of 1 is, see, the value of, this is the values, value of 1 equals to, value of 1 equals to 3. So, I have to take here value of I 1 equals to 3, and same as we required what? We required weight of I we required. So, here also weight of I equals to, what is the I value? Weight of 1, okay, weight of 1. What is the weight of 1 equals to? What is the input value? Weight of 1 is 2. So, I have to take weight of 1 equals to 2. Okay, now we got all the values to implement this equation. If you implement these values in that equation, what is the value we will get? T of 1 comma 1, that equals to max of T of 1 minus 1 comma I 1 comma 3 plus T comma 1 comma 1 comma 1 comma 2, okay, that equals to max of, here if you T of 1 comma 1, what is the value? 0 comma and 1. Okay, then here T plus T of 1 comma 1, 0 minus, and what of 0 comma minus 1. So here if you get anywhere negative values, we have to ignore that weights. Okay, we have to ignore this point. Sorry, ignore this part. Ignore. Why you have to ignore? We are getting here negative values, so we have to Ignore. Okay. What is the value here? Max of t of 0 comma 1. Oh, sorry. Here, what is the value? T of 0 comma 1. What is the t of 0 comma 1 value? Now, according to the table, what is the t of 0 comma 1? T of 0, it is the 0 value, 0 throw and 1. What is the value? 0. So, here also, so here 0 comma 1 value is what is the 0 comma 1 value? 0 comma 1 value is 0. So, here also we have to do, we will get 0 comma 1 is 0. So, we have to fill what t of 1 comma 1 is t of 1 comma 1 is 0. We have to fill this value with 0. We have to same like that. We have to same like that. After completion of first one, we have to calculate t of 1 comma 2 value have to find out. This value have to find out. Okay. Same, this value has to be find out. T of 1 comma 2 value have to find out. And how to calculate same by using this formula. I have to calculate t of 1 comma 2. So here I am taking t of 1 comma 2 means I value equals to 1, j value equals to 2. Value of I equals to value of 1. I value 1 comma t. Value of 1 equals to 3. Weight of I equals to weight of 1 equals to 2. These are the values we are taking from input data. Okay. Now you are implementing these values in the formula. If you are implementing these values in the formula, what you will get in the implement, if you are implementing here t of 1 comma 2, if you are implementing directly here maximum of t of 0 comma 2 comma 3 of t. Now if you are implementing here max of, what is the value? Max of 0 comma 2, t of 0 comma 2, what is the value? According to the table, t of 0 comma 2, okay, t of 0 comma 2 value is 0. So here also we are taking 0 comma 3 plus t of 0 comma 0. According to this, 0 of 0 comma 0 means 0. So here also 0. What is the value? If I count here, maximum of 0 comma 3 plus 0, 3. Okay, by comparing here maximum of, which is the maximum value 3. So it is the 3. So t of 1 comma 2 is 3. It is 3. Okay, and now we have to calculate t of 1 to 1 comma 3 value have to calculate. T of 1 comma 3 value have to calculate. Here I am writing directly. Here what is the I value here? I equals to 1, j equals to 3. And what is the value of I? Value of I equals to 1. So if I equals to 1 kabatti, so what is the value? Value of I equals to 3. And what about weight of I? That equals to 3. That equals to, what is the value? 2. Sorry, I equals to 1. So here also the weight is 2. So same, we are implementing these values to find out t of I comma 3 in this equation. Okay, if you implement here, the final value is t of 1 comma 3 equals to, what is the value we will get? Max of t of 0 comma 3 comma 3 plus t of 0 comma 1. Okay, if you write max of 0 comma 3 plus 0, that equals to 3. Okay, okay, here we have to fill 3, 1 comma 3 is 3. And what about next one? T of 1 comma 4, t of 1 comma 4. So we have to write t of 1 comma 4. Here I am writing directly. I am not writing what is the I value, what is the value of I, what is the value of I. Okay, I am writing directly. Okay, here t of 1 comma 4 means what is the answer we will get? Max of 0 comma 3 plus 0. Okay, I am writing directly here, don't confuse. Here 0 comma, so max of 0 comma 3. What is the maximum value here? 3. So 3. I have to consider 3. Okay, in this value we have to take maximum value. So 3 is considered. That is t of 1 comma 4. And like that, t of 1 comma 5. What is the t of 1 comma 5 here? I equals to 1, j equals to 5. And what about value of I? Value of I equals to 1. So what is the value? Value of I equals to 3. And what about weight of I here I equals to 1, so what is the value? 2. Okay, same these values have to implement this for equation. If you implement this equation, what you will get? T of 1 comma 5 equals to maximum of T of 0 comma 5 comma 3 plus T of 0 comma 3. Okay, that equals to maximum of 0 comma 3 plus 0, that equals to 3 plus 0. What is the maximum of 0 comma 3? 3. Okay, I have to fill this. 0 comma 3 is 3. Okay, similarly up to we find out that first two values. Okay, first row values. And what about second row values? We have to find out the second row values. Okay, actually if you calculate this first two matrix also, in this row also we'll get all zeros. In this row also we'll get all the zeros. We have to calculate this part. Okay, how to calculate? Next one we have to consider second row. Okay, next one we have to consider second row. What is the second row? This one, this is the T of 2 comma 2, T of 2 comma 3, T of 2 comma 4, T of 2 comma 5. Like that we have to calculate T of 3 comma 2, 3 comma 3, 3 comma 4, 3 comma 5. Like that we have to fill all the rows. Okay, here I am writing directly. For time being I am writing directly values. Okay, after that here we will get 3, here 4, 4 and 7. And what about here? 3, 4, 5 and 7. Here 3, 4, 5, 7. In exam you people have to write complete derivations. If you skip means they won't give full marks. Okay, here after completion of this, what is the solution? After completion of this, what is the solution? Okay, here what is the maximum value? We have to take the in the table right corner value. We are getting the maximum value is 7. We are getting the maximum value 7. Here the 7 is represents the value, the maximum possible value which can we put in the knapsack bag. Okay, according to all the items inside the bag we can put the maximum value is 7. It represents the maximum possible value which we can put inside the bag. It is the maximum value we can put inside knapsack. Okay, that means the maximum weight we can put inside the bag is 7. Inside the bag is 7. Okay, this is the maximum value. So what are the items we can store? Items we can store means, okay, if you are traveling from bottom to upside, 7. Okay, next if you are forward, one step forward, here also 7. Okay, again if you forward one more step, here also 7. And if you step one more step, here also 7. Okay, where the values are changed, when you are moving bottom to upside, where the value are changed, okay, before changing item and after changing item, these both will be we can place inside the bag. Here the 7, here also 7, here also 7. And what about here 3? So this item is, and this item and this item. So this first item and second item we can place inside the knapsack bag. Okay, if you place these two items, we will get more value. The profit value is 7. The profit value is 7. The maximum height we can put inside the knapsack bag is 7. The items are, okay, the items we can put are first item and second item. We can select what is the first item value is, according to input value, the first item value is 3 value, second item value is 4. And what about weight? 2 plus 3, so weight is 5, satisfying the value is 7. Okay, this is about the 0 by 1 knapsack problem. Don't confuse. If you have any comment, if you have any doubts, please ask me in comment section. Okay, thank you everyone. Hello everyone, welcome to my YouTube channel Concept Clear. In today's video, I will explain traveling salesperson problem using dynamic programming. Okay, first of all, those are visiting my channel first time, please subscribe our YouTube channel Concept Clear for further classes. Okay, now coming to our topic in traveling salesperson problem using dynamic programming. In last class we seen what is the all page shortest path problem using dynamic programming. Okay, here what is the problem? Traveling salesperson problem. Here traveling salesperson problem consist of salesmen and set of cities. Here, what is the meaning of salesman? Salesman has to sell their products, and what is the meaning of set of cities means he has to travel all the cities and he has to sell his products. That is the salesman and cities problem. Okay, here what is the problem? The problem is here we need to find out the salesperson has to travel all the cities and returning to the same city. For example, if you take any four cities from Hyderabad, Vijayawada, Warangal, and Tirupati. Okay, here the salesperson in the place in the Hyderabad, for example, it is the Hyderabad, and it is the Vijayawada, and it is the Tirupati, and it is the Vizag. Okay, assume these are the four cities. Okay, here the salesperson is located in the Hyderabad. He has to visit all the cities. Okay, he has to visit Vijayawada as well as Tirupati as well as Vizag, and the final destination should be again the starting location. Okay, in which way he travels all the cities, he will get minimum cost. Okay, here we need to find out the salesman has to travel to all the cities, returning to the same city, and the final cost should be minimized. Okay, here the salesperson has to travel starting from Hyderabad. He has to visit Vijayawada, Tirupati, Vizag, and finally he has to reach again Hyderabad. Here, which route he will follow, he will get minimum cost. We have to find out the minimum cost. Okay, the main points here. Okay, see here, the person wants to minimize the total length of the trip. He has to minimize the total length of the trip, as well as the total cost of the trip. Okay, if a salesperson visited his own place, the traveling cost is 0. Okay, here the salesperson is visiting in the same city Hyderabad, then the cost is 0. Okay, then the cost is 0. Okay, let take g of I comma s be the length of the shortest path at vertex I. Okay, going through all the vertices in yes. Okay, here what is the meaning of s means? S is nothing but set of cities. Here S is nothing but set of cities, and the terminating at vertex 1. Here what is the meaning of G of I comma S? I is starting city and S is set of other cities. Okay, these are the points. Next, what is the next point? Here the function the function g of 1 comma vertices of vertex minus of 1 is the length of the optimal salesperson tour. Okay, that is the length of the optimal salesperson tour. Okay, if you take here, what is the formula here? G of 1 comma v minus I, that equals to minimum cost of C2 less than K less than or equals to K less than or equals to N. Okay, that equals to C of Ik plus G of K comma V. This is the formula for traveling salesperson problem. Okay, this is the formula for, and the generalized formula. Okay, this is the standard formula, and generalized above formula is, okay, the general formula is, the second one is the generalized formula. We have to use this formula in this problem. Okay, what is the formula here? G of I comma S, that equals to minimum of J2S. Okay, that equals to J2S. Here what is the J is other than the starting city. Okay, here I am taking J of starting city comma set of cities. Starting city comma set of cities. Here J2S means it is other than the starting city. Okay, that equals to what is the formula? C of Cij plus G of 1 minus S minus of I. Okay, this is the standard formula. Okay, this is the standard formula. Now we will take one example. We will implement that example in the live class only. Okay. Okay, see here. This is the example. In this example, I am taking a graph. Here graph contains 4 cities, that is equals to 4 vertices. And what is the problem here? Let's start from first vertex. We have to visit. We have to start from first vertex. We have to visit all the cities, 2, 3, 4, all the cities, and find out the shortest path to visit all the cities. ఇక్కడ ఏం జరిగింది, ఇక్కడ మెయిన్ థింగ్ ఏంటంటే మనం ఫస్ట్ సిటీ స్టార్ట్ అవ్వాలి, సెకండ్ సిటీస్, థర్డ్ సిటీ, ఫోర్త్ సిటీస్, అలా ఆల్ సిటీస్ మనం ట్రావెల్ చేసి వీ హ్యావ్ టు ఫైండ్ అవుట్ వాట్ ఈస్ ద షార్టెస్ట్ పాత్ టు విజిట్ ఆల్ ద సిటీస్. మనం అన్ని సిటీస్ తిరిగినా కూడా మనకు తక్కువ కాస్ట్ ఏ రూట్ లో అవుతుంది అది మనం ఫైండ్ అవుట్ చేయాలి. ద కాస్ట్ ఆఫ్ అడ్జసెంట్ మ్యాట్రిక్స్, ఓకే, ఫ్రమ్ దిస్ we have to find out the shortest path. Okay, according, this is the graph and this is the values. Okay, here it is the I values and this is the J values. Okay, what we have to do here, we have to find out here, this is the example problem. We have to find out minimum cost of the tour. Okay, this is the example graph and example values. Okay, let's start our tour. Okay, let's start our tour means what? We have to start our tour from vertices 1. We have to start from vertices 1. So I am starting here vertex 1. Okay, see here I am starting vertex 1. What is the vertex 1? At vertex 1, okay, here what is the formula? I comma s. Here what is the I value? 5. Okay, I value is I. Okay, we have to implement the vertex 1 in the second equation. In this second equation, if you implement this equation, what you will get? 1 comma 5. 1 comma 5, that equals to what? That equals to, we have to, that equals to Ci of 1. Here I value is 1. So 1 less than or equals to n. So what is the value? Ci of 1. That is the, okay. Next, what is the C21? C21 equals to, okay, see here, G of 2 comma 5. G of 2 comma 5. C of G comma 2 5 means what? C2 comma C21, that equals to 5. Okay, where we will know these answers means this we know these answers in the example graph. Okay, see here, C21, C2 is 5 and 1 is 5. So this is the 5. And G of 3 pi. G of 3 pi equals to C of 31. What is the 3 of 31? That equals to 6. Okay, next, G of 4 comma pi. What G of 4 comma 5 means what? G of 4 comma 1. What is the 4 comma 1 value is? Again, 4 comma 1 value is, it is 8. It is 8. No, actually this is the wrong and this is the 8. Okay, this is the 8. Okay, now, okay, what about these values? These are values from person starting from one vertex. Okay, is the values from starting from first vertex. Now using the second equation, we have to find out person starting from first vertex, he has to visit all the vertices. Okay, these are the initial values. Now we have to implement the second. Now we have to implement these values in the second equation. We have to find out the shortest path from the person. The salesperson has to starting from first vertex to second vertex, then third vertex and final vertex. Okay, in which way if he follows, we will get less cost, less shortest path. Okay. Okay, what is the formula here? The formula is G of I comma S, that equals to minimum of J2S and Cij, this is the formula. We have to implement this formula. Okay, now I am implementing. Okay, now to calculate using second equation. Okay, if you are using second equation, what is the formula here? G of I value. What is the I value first? I value is 1, so 1. Okay, 1. And what about remaining? These all are set of cities. We are not considering, so set of cities. What is the I value? First I value is 1, so we are starting from 1, so I value is 1, and this is the S value is remaining set values. Remaining values are set values. That equals to same formula. We have to write for 3 times. Okay, minimum of C12. It means what? If the person is starting from 1 to 2, so visiting second city. Okay, here visiting second city means this is the second city will become outside, and what about this? This is the S value. Okay, visiting second city. So G of 2, 3, 4 local endukunnayante, these are the visiting, these are the not visiting cities. Visiting, currently visiting is 2. Same like that, G of 1, 2, 3. 1, 2, 3 కి వెళ్ళినప్పుడు visiting 3 and 2 and 4 are the silent. And here also C2, C1, 4, here visiting 4 cities. So we are writing visiting city outside of the set, and 2, 3 are the not visiting. So it is the inside the set. Okay, this is the main equation. This is the not a main equation. This is the main implement part. Okay, here we know. Okay, now we have to calculate this part value and this one value and this one value individually. We have to calculate this part value and this part and this part. Now finally we have to merge this all. We will get our result value. Okay, here what I have to do? To calculate C12, C13, C14 values. I have to calculate C12, C13, C14 values. Okay, now how to calculate? Okay, to calculate individually you have to do calculation. Okay, here I am taking C of the first part. I am taking here C of G of, okay, see here in this one. Okay, in this one I am taking G of 2, 3, 4. We know what is the C12 value, so we have to consider, we have to calculate this part. Okay, we have to calculate this part, and here also we have to calculate this part, and we have to calculate this part. Okay, to calculate what is the value here? Again the question formula, the part is G of 2, 4. Okay, here we have to take this is the I value and this is the S value. Okay, we have to treat this is the I and J. Okay, same equation you have to repeat. Same equation. Okay, what is the same equation? If you write the same equation, we will get minimum of C23 plus G of 3 of 4, comma C of 24 plus G of 4 of 3. Okay, this is the thing. Okay, now we have to do it. Minimum of what is C23? Okay, what is C23 in the according to the graph? C23. C23 is what? C23 2 3 value is 9. So it is 9. So 9 plus G of 3, 4. What is the value? We don't know. Then what about C24 value? According to this graph, according to input value, 24 value is 10. So it is 10 plus G of 4 of 3 again. Okay, again we don't know what is the G of 3, 4, G of 4, 2, 3. So again we have to calculate these two values individually, and we will implement these two values again here. Okay, again now we have to calculate this part. So G of 3, 4. Okay, again same like that. This is the I, it is the S. Okay, same formula. Again I have to do here sub part also. Okay, if you are implementing a sub part, what is the value here? Minimum of C34 plus G of 4 pi. Okay, what is the value? Minimum of C34. C34 value is what? C34 value is 12. Okay, minimum of 12 plus And what is the value here? 8. Okay, 4 pi is 8. We know 4 pi value is equal to 8. So what is the value? Total is 20. Okay, this is the 20. Again, what about this part? This part I have to find out. Okay, this part means g of 4 of 3, that equals to same formula. It is the I, it is the S. We have to treat as the I comma S. So what is the value? Minimum of C of 4 3 plus G of 3 comma 5. G of 3 comma 5, that equals to G 4 3 equals to G 4 3 4 3. Now 4 3 equals to 3 9 plus G 3 5, that equals to 6, that equals to 15. So what is this value? This entire value. So here this entire value becomes 20. This value becomes 15. ఎక్కడ వచ్చాయి? ఇట్లా మనం క్యాలిక్యులేషన్ కాబట్టి we know the values are 20 and 15. Okay, now again this equation, what is the values here? Minimum of 9 plus, okay, minimum of 9 plus G of 2 value, what is the value? 20 comma, and what about this side? 10 plus 15. Okay, I have to find out this one. Minimum of, what is the value? 9 plus 29 comma 25. And here what is the minimum cost? Okay, the minimum of 29 and 25, what is the minimum value is 25. So the first part value is 25. Same like that. Okay, similarly we have to calculate G of 3 comma 2 4. Sorry, we have to calculate this entire part, and again G of C of 1 comma 4. Okay, this value you have to find out. This value also we have to find out, calculate it separately. Okay, for time being I'm writing directly. Don't confuse. I'm not calculating same procedure like G of I comma S. We have to implement the same formula in the second part and third part also. For time being I am writing the values are directly here. Okay, don't confuse. Okay, see here, for time being I am calculated offline. Okay, here G of 2 comma 2 4, that equals to, is the equation. Here again we have to calculate this part separately. This part also calculate separately. I am writing directly. For time being here, if we calculate this part we will get 18, this part is 13. Okay, we are implement these values here. Minimum of 41 comma 25. In this two, which one is the minimum value? 25. So the second part value is 25. And what about part? Last one is C of G of 4 comma 2 3. Okay, again we are calculate this one. We will get minimum of 23 plus 27. In this, which one is the minimum value? 23. So what we got? We know the complete equation. Now we have to write this entire values in a single equation. Okay, after have to write it. Okay, those three parts I have to implement here. This is the C of values, G of values. Okay, if you implement this one, what we will get? Final answer is minimum of 10 plus 25 comma 15 plus 25 comma 20 plus 23. What are the values? Okay, we got these values, and C12 is 10, C13 is 15, C14 is 20. Okay, we have to write. Okay, finally what we get here? Minimum of 35, 40, 43. That equals to, what is the final answer here? 35. What is the 35? The optimal tour for the graph has length is 35. The optimal tour for the graph is 35. Graph is 35. Okay, the optimal tour. Okay, which way you have to travel? Okay, here this is the sun, and the final route is the optimal tour is 1 to 2. First it has to travel 1 to 2 and 2 to 4, then 4 to 3, again 4 is 1. Okay, this is the optimal tour. Okay, it means what? It has to travel from first 1 to 2, then 2 to 4, then 4 to 3, 3 to 1. This is the path it has to travel. Okay, now we have to assign the values. Okay, what is the 1 to 2 values? Now we have to draw the graph. Okay, how to draw the graph again? Sorry, 1, 3, 2, 4. Okay, how to draw the graph? 1 to 2, the graph is 10. Here 2 to 4 is 10, and 4 to 3 is 9, and 1 to 6 is 3 to 1 is 6. Okay, if we calculate, if you travel 10 to 10, 10, 9. What is the value? 10 plus 10 plus 9 plus 6, that equals to 35. The total cost is 35. The total cost is 35. Okay, which produce, this is the total cost is 35. Okay, this is the class about traveling salesperson problem. If you have any doubts in this or in our lecture, please ask me in comment section. Okay, thank you everyone. Hello friends, welcome to my YouTube channel. Concept clear. In today's class, I will explain optimal binary search tree using dynamic programming in the subject of design and analysis of algorithms. Okay, here it is one of the important topic in the third unit. Okay, what is the meaning of OBST? First of all, to start OBST, optimal binary search tree, first we should discuss what is a binary tree. Okay, a binary tree is nothing but elements less than the root. The elements less than the roots are left side and greater than the root are right side. Those trees are called binary search tree. Okay, if you take any tree, the root element ki left side ఉన్న elements అన్ని తక్కువ వాల్యూగా ఉండాలి, రైట్ సైడ్ ఉన్న ఎలిమెంట్స్ higher values ఉంటే those type of trees are called binary tree. For example, here I am taking a set of elements are 1, 2, 3, 4. Okay, by using this we can draw multiple binary search trees. Okay, for example, I am taking here root is the 3 is the root element, and if you are taken 3 is the root element means what is the left side condition? All the elements are smaller values. So 3, 2, 1 this is the left side and right side is the greater than value. Okay, again we will get, if you take 2 is the root element. Okay, what is the left side element? Left side element is 1 and right side elements are 3 and 4. Okay, here this is the binary tree and is also one of the binary tree. Okay, here this is the about binary tree. What is meaning of optimal binary tree? A optimal binary tree is nothing but for given set of numbers we can build multiple binary trees, but among all the binary trees, whichever takes minimum number of steps to reach the key, then it is called optimal binary search tree. Okay, here searching means what? Suppose you are searching a particular value, particular key. Okay, in this among all the binary trees, which one will be reached first? Those trees are called optimal binary search tree. మనకి ఇక్కడ వచ్చిన మల్టిపుల్ బైనరీ ట్రీస్ లో మనకు కావాల్సిన ఎలిమెంట్ ని ఏ ట్రీలో మనం సెర్చ్ చేస్తే ఎలా సెర్చ్ చేస్తే మనం తొందరగా రీచ్ అవుతామో దాన్ని ఆప్టిమల్ బైనరీ సెర్చ్ ట్రీ అంటారు. ఫర్ ఎగ్జాంపుల్ హియర్ ఐఎమ్ సెర్చింగ్ ఫర్ 1, then the key is 1. Okay, the key is nothing but what? Searching element is called key. Okay, for example, you are searching for 1, then 1 is your key element. Among all the possible binary trees, whichever binary tree will use it to reach the key with minimum number of steps, then that will is called optimal binary search tree. Okay, clear? This is about the optimal binary search tree definition. Now we will see what are the formulas in dynamic programming. In optimal binary search tree we have 3 equations. We have very important of 3. These are the very important formulas. Okay, if you know this formula we can write our own in examination also. Okay, see, this is the C of I comma j, This is the W of I comma j. This is R of I comma j. Okay, we will discuss later. Okay, what is the meaning of R of I comma j means this is the k value. W of I comma j is the formula. C of I comma j. Here in this equation also we are using W of I comma j. So we have to execute. We have to find out this value first, then second and last one. Okay, actually this is the second one. This is the first formula. This is the third formula. Okay, for this example, for this optimal binary search tree, we will discuss one live example. Here I am taking example values are n equals to 4. What is the meaning of n equals to 4 means 4 elements, and those are elements are called A1, A2, A3, A4. Okay, what are the element values? The element values are A, B, C, D. Okay, A1 is nothing but first element, A2 second element, A3 third element, fourth element, and respectively A, B, C are the these are the values, element names actually. Okay, some P equals to P is nothing but successful probability values. Successful probability values. Here I am taking here P equals to P1, P2, P3, P4. P1, P2, P3, P4, and we can also take it as the P1, P2, P3, P4, and what is the value for P1 is 3, P2 3, P3 1, P4 1, and same as sum of unsuccessful probabilities Q values, Q set. What is the Q set here? Q equals to 0, 1, 2, 3, 4. These are the Q unsuccessful values. These values are 2, 3, 1, 1, 1. Okay, and finally what I have to do? I have to do here. Here we have to construct optimal binary search tree. We have to construct optimal binary search tree for these values. For these values, how to draw? We will discuss here. Here, what is n value? N equals to 4. Then T04. We have to find out T04. What is the meaning of T04 means? We need to find, in order to find out T04, we need to find before terms. Okay, T04. Before terms what? T00, T01, T02, T03. These terms we have to find out first. So, like we have multiple, to find out this, we have multiple cases. We have to take multiple cases. What are the cases we have to take means? Okay, remember this is the cases very important. J minus I equals to 0 case, J minus I equals to 1, J minus I equals to 2, J minus I equals to 3, J minus I equals to 4. These are the cases we have to calculate. Okay, first I am taking here case 1. Here I am taking case 1. What is the case 1 here? Case 1 equals to J minus I equals to 0. J minus I equals to 0. It means we have to take any two values. We have to take any two values. The value should be, result is 0. Okay, here it means T of 0, 0. Okay, here if you have any x value and y value both are same, then we will get 0. Okay, in the combination, if you have compare with I and j value both are same, then we will get the 0 value. So here T00, T11, T22, T33, T44. That equals to what? T of I comma j, that equals to 0. We directly will get the 0 answer. Okay, so here what I have to do after these 4, if I have in this case 1, we have to find out these terms values you have to find out. Okay, these terms. Okay, and next, what is the first term here? The first term is T00. We are finding T00. What is the T00 here? Here T00 means what? Here I and j are equals. I and j are equals each other. We have to follow initial formulas. Here I and are 0. So we have to follow initial formulas. What I told the formulas first we have to find out the W value. First I have to find out the W value. Sorry. First we can find out any value. First here I am finding W value. What is the meaning of W value? What is the equation? W of I comma j. Okay. What is I comma j? W of I minus, sorry, I 0 comma I minus 1, 0 minus 1 plus P of j. What is the j value here? J value is 0. P of 0 plus Q of j. Q of 0. Q of 0. If we calculate this, what is the answer? W of 0 comma 0 minus 1. So we will get W of 0 comma 0. Okay, here Q of 0, Q of I value is 0. And what about this one? Q of j value also 0. Okay, here what is the W of 0 0? It is 0 plus P of 0. What is the P of 0 here? P of 0 is, there is no P of 0. So no need to consider here. And Q of 0. Q of 0 is what? Q of 0 equals to 2. So that equals to 2. So what is the value here? W of is also 0. It becomes 0. So here what is the value? W of I comma j equals to 2. I comma j equals to 2. And what about next one? That is the, in this term we will find out the first formula. And what is the second formula? C of I comma j, that equals to, both are same, means that is equals to 0. And next what I have to find out? R value. What is R value? R of I comma j, that equals to 0. That equals to 0. Okay, same like that. This is the first term. In the first case, first term. Next what I have to find out? T11, that is the second term. Okay, here also both are same. I am directly writing C11 equals to, okay, it equals to 0. R11 equals to 0. And what about W11 equals to, I have to write the same like this. Here also we will get all the zeros. So zeros, and W of 1, Q of 1 equals to, so here we will get Q of 1 equals to 3. Q of 1 equals to 3. And same like that T22. Okay, here I am writing directly T22. Here also C2 comma 2 equals to 0. R2 comma 2 equals to 0. And W equals to 2 comma 2. Okay, if you implement in this equation, we will get what? We will get W of 2 comma 2 minus 1 plus P of j plus Q of j. So what is the value? W of 2 comma 2, W of 2 comma 1 plus, okay, next W of 2 comma 1 plus P of j. What is the P of j value? P of j value is 2. 2 value is 3. So yeah, here in the first equation we will get Q of 1. Here also we will get Q of 2 value. So what is the Q of 2 value is? Again 1. Q of 2 equals to 1. Okay. Similarly, if we calculate T of 3 also, C of 3 is 0. R of 2 comma 2 equals to 0. W of 3 comma 3 equals to Q of 3. It will come 3. Q of 3, that equals to again 1 according to input data. And T of 4 equals to C of 4 comma 4, that equals to 0. R of 4 comma 4 equals to 0. W of 4 comma 4 equals to Q of 4, that equals to also 1. Okay, now we completed first case. Now we have to do second case. What is the second? This is the first case values. Okay, for every time you are finishing the case values, we have to note these values in a separate page. We have to note these values as a separate page like this. Okay, we have to write all the values. First case T of 0 0 value, T of 1 1 value, T of 2 2 value, 3 3 value, 4 4 value. I have to write in a separate table. Okay. Next what I have to do? Next we have to take second case. Okay, what is the second case here? In the second case, this is the first case, this is the second case. What is the second case here? Case 2. Okay, I'm writing case 2. What is the second case? Case 2 is j minus I equals to 1. J minus I equals to 1. Consider j minus I equals to 1. Okay, what are the terms? Under this, what are the terms we will get? Okay, where we will get the 1 value? T01, T12. It means the difference is 1. Okay, T23, T24. Okay, sorry, 3, 3, 4. These are the terms. Okay, for first term I am finding here. What is the first term? T01. T01 term, we have to find out the W value. We have to find out the W value, C value, W value, R value. First here I am finding the W value. W of T01. Okay, here I value is 0, J value equals to 1. Okay, 0, 1. Okay, next. What is the formula? W of 0 is the formula W of I comma J minus 1. J value is 1. 1 minus 1 comma, plus, in the equation is the plus P of J value. What is the J value here? 1. So, P of 1 plus Q of J value. Q of J value is what? Again 1. So, what is the answer here? The answer is W of 0 comma 0 plus P of 1 value is what? P of 1 is 3. So, here we have to write 3. Here also Q of 1. What is the Q of 1 is 3. So, it is also 3. And what is the answer? W of 0 0 equals to, we know W of 0 0 equals to, check inside the table. W of 0 0 equals to what? W of 0 0 equals to 0. We updated in the table. So, here what we will, W of 0 0 equals to 2. So, what is the answer here? 2 plus 3 plus 3, that equals to 8. So, T of 0, T01 is equals to 8. Now, we have to calculate C of 0 comma 1, that equals to, what is the formula? Minimum of 0 less than k less than or equals to 1. Okay, here by looking this formula, what we can say? K, what is the k value? 0 less than k. K value is not less than k and also not equals to k. So, what is the value? I can find out k equals to 1. The possible term is k equals to 1. Okay, what is the formula here? C of I comma, what is the I value here? 0, 0 comma, k minus 1, k value equals to 1. So, what is the value? 0, 1 minus 1 is 0 plus, what is the formula here? C of k comma j. C of k value is 1. So, 1 comma j value is 1. Okay, then plus W of 0 comma 1, 0 comma, W of I comma j means 0 comma 1, that equals to W of 0 comma 1 is, what is the value here? W of 0 comma 1. Okay, I am writing here 0 comma 1. So, you are implementing this formula here. C of 0 0 is 0 plus C of 1 1 is 0. W of 0 1 is, here we are getting the 0, W of 0 1 equals to 8. So, 0 plus 8, that equals to what? That equals to, answer is 8. So, update C01 value also. Update C01 value also. Next, now we have to take R value. Now, we have to find out R value. Now, R equals to what? R we have to find out. So, now R equals to I comma j equals to k. The formula is R equals to I comma j, that equals to k. Okay, in this previous term, in the derivation part, what is the k possible thing? K possible thing is 1. The k is, only possible thing is 1. So, here k value is equals to 1. So, it is the third formula. Now, the second term is also, in the second case, first term is completed. What is the second term? T12. So, here I have to find out T12. That equals to, I value is 1, j value equals to 2. Again, we have to find out the same formula. W of 1 comma 2, that equals to, I am writing directly here, W of 1 comma 1 plus P of 2 plus Q of 3. If you write, we will get the answer is W of 1, sorry, W of 3 comma 3 comma 1 comma 1 means 3 plus 1, that equals to 7. So it is the W of value. And what about C of 1 comma 2? That equals to minimum of 1 less than K less than or equals to 2. Okay, according to this condition, 1 less than K equal to 1 less than K less than or equals to 2. So what is the condition here? K is only for 2. Okay, K ఒకటి ఎక్కువ ఉండాలి, రెండు కంటే తక్కువ ఉండాలి. సో K equals to 1. So I am implementing the value C1 comma 1 plus C2 comma 2. Okay, check the equation here. Okay, this is the equation. Okay, plus W of I comma j, I value is 1, j value 2. So W of I comma 2. Okay, if you calculate this one, we will get 0, 1 comma 1 is 0 plus 2 comma 2 is 0 plus 1 comma 2 is, we will find out here 7. So it is the 7. So what is the total value? 7. Sorry. Okay, here C11 is 7. So what is the R value? The condition is R of I comma j, that equals to K, that equals to what? K value is what? 2. So it is the R of I value. Okay, next we have to calculate T of 2, 3 value. Okay, here I equals to what? I equals to 2, j equals to 3. J equals to 3. Now j equals to 3. So what is the answer here? J equals 3 means I am writing here directly W of 2 comma 3, that equals to W of 2 comma 2 plus P of 3 plus Q of 3, that equals to what? W of 2 comma 2 is 1 plus P of 3 equals to 1, so P of 3 that equals to 1 plus Q of 3 equals to 1. So what is the answer is 3. Okay, here W of value is also 3. Next, C of 2 comma 3. What is the answer here? What is the equation? Minimum of 2 is 2 less than K less than or equals to 3. Okay, according to this condition, K is greater than 2 less than or equals to 3. So K equals to 3. The condition is 3. So here I am writing C of 2 comma 2 plus C of 3 comma 3 plus E of W of 2 comma 3. What is the answer here? 0 plus 3, that equals to 3. Okay, C of 2 comma 3 is also 3. So what is the R value? R equals to I comma j. In this term we consider K equals to 3. So here also K equals to 3. Okay, every term we have to update C value, W value, R value. Okay, next T of 3 comma 4. Okay, T of 3 comma 4. Here what is I value? I value is 3, J value equals to 4. Okay, here I am finding W of 3 comma 4, that equals to W of 3 comma 3 plus P of 4 plus Q of 4. What is the value? W of 1 comma 1 means 3 comma 3 means 1 plus 1 plus 1, that equals to 3. Okay, and C value, C of 3 comma 4, that equals to minimum of, the formula is I value is I less than K less than or equals to J. So 3 less than K less than or equals to 4. So here what is the possibility is K equals to only possible thing. So I am writing same equation C of 3 comma 3 plus C of 3 comma 3 W of 3 comma 4. Okay, that equals to what? 0 plus 3, that equals to 3. And what about R value? R equals to I comma j. So that equals to K. Here possible thing is K equals to 4. So K equals to 4. Okay, now we completed case 1 and case 2. Now again we have to update our calculated values in a table. Okay, see here we have to update the table. It is the first case and second case. First case terms are 5, second case terms are 4. Same like that, we have to calculate the remaining 3 cases. Remaining 3 cases, and for every time we have to update the table value. For time being, this optimal balance tree video is getting more than 30 minutes. So I am calculated previously. I am explaining the paper on paper. Here the case 3. Here what is the case 3? I comma j equals to 2. So what are the terms we will get? The terms are t0 comma 2, t13, t24. Okay, here j minus I equals to 2. That condition means the I value and j value, the difference should be 2. Okay, t02, t13, t24. These are the three terms I have to find out. Okay, this is the first term. We are finding the w value. The final answer is 12. Same previous చేసేమో దానిలాగే చేయాలి. ఇక్కడ ఎక్కడ కన్ఫ్యూజ్ అవ్వద్దు. Very simple. Same like that, w value and c value. Okay, here see here what is the difference? The same method here also. I value is 0, so 0 less than k less than or equals to 2. So here what is the possible terms? The k equals to 1 is possible, k equals to 2 is possible. So here first time we are writing k equals to 1, this is the value, k equals to 2, this is the value, plus of 0 2. Okay, here which one we have to take? Okay, finally you are calculating k equals to 1 to consider is 7 వస్తుంది, k equals to 2 considering the will get 8. Okay, finally which one you have to calculate, which one you have to consider? Okay, our problem is minimize the problem. So which one is the less value? Which is the less value? That value will be big. Here we are getting 7, here we are getting 7. So we'll pick this 7 value. Okay, and 7 plus 12 equals to 19. So T02 C value is 19. And R equals to I comma J equals to K. Here I comma J, K value, what is the K value? K value 1 only, 1 and 2. Which one you have to consider means which value are considered here? So 7. So what is the 7 value? K equals to 1 means we are getting 7. So here also we are consider k equals to 1. Okay, same like that, T13. Here also we are getting k value equals to 2 comma 3. Here we are considering 3 value. So it is belongs to k equals to 2. So we are considering the r equals to 2. Same like that. T024 also. Here I am writing, for time being I am writing here w value, c value, r value directly. Okay, after completion of third case, we have to update the tables. Okay, see, we have to update the first case, second case, third case values. Okay, next I have to calculate the fourth case. What is the fourth case here? The fourth case, the condition is j minus I equals to 3. J minus 1 equals to 3. The difference should be 3. Okay, here T0 comma 3, T0 comma 4. Okay, these are the two cases. Okay, these are the two terms. T03. Sorry, this is the T14. T03, T14. Okay, same method, same formulas we have to implement. Here also I am finding the W value, here C value, and here R value. Same thing. Here, what is the K value? K value contains 0 less than K less than or equals to 3. So what is the possible things? K equals to 1, 2, 3. Okay, it is the 3 possible things means we have to consider K equals to 1, K equals to 2, K equals to 3. Okay, finally we are calculating. Here we are getting 12, here we are getting 11, here we are getting 19. Okay, among these 3, which one is the least value? 11 is the least value, so we are considered the 11. So here 11 plus 14, that equals to 25. And what about K value? Which one have to consider? Which was the least minimum value here we are getting? That K value have to consider. So here K equals to 2. Here also R of I comma J equals to K. Here K equals to 2. Okay. Next term is T14. I am writing here directly W value, C value, R value. And what about the last case? In last case, K equals to, so J minus 1 equals to 4. Here we have the only one possible term, T04. T04 is the only one possible term. So T04 equals to T04. We have to write, again we have to implement three equations, W equation, C equation, R equation. So W equation, if we are calculate, we are getting 16 is the answer. Okay, and C of 04, here minimum of 1 less than K less than or equals to 4. 1 less than K less than or equals to 4. That means 0 less than K, that K less than or equals to 4. That equals to K equals to 1, K equals to 2, K equals to 3, k equals to 4. These are the 4 possible terms. These are the 4 possible terms. If you implement these 4 terms, what is the k value 1, k value 2, k value 3, k value 4? Okay, for every term we have to calculate like this. We will get the result is, we will get the final result is 19, 18, sorry, 19, 16, 21, 35. Okay, among these 4 values, which one is the least value? 16 is the least value. So what is the k value for this one? 2. Here also we have to consider the k value 2. So here 16 plus 16 equals to 32. C value is equals to 32. And what about R value? R of I comma j. I comma j means 0 comma 4. That equals to k. What is the k value here? We consider 2. So here also k equals to 2. Now we are completed all the terms. Okay, now we need to start consider the optimal binary search tree. Okay, here finally after calculating all the values, we build a table like this: first case values, second case, third case, fourth case, and fifth case values. We have to write all the values in a single tabular form. Okay, like this you have to write all the tabular form values. Okay, next after calculating these values, what we have to do means we have to consider the tree. We have to consider the optimal binary search tree. How to construct? Okay, root element is I comma j, that equals to k. And what is the condition? Left side is the condition. Okay, see here, this is the general diagram for construct. Root element is I comma j equals to k. What is the left side is ri comma k minus 1, and right side is rkj. Okay, assume here root element is r0 comma 4, that equals to k. Here what is the 0 comma 4 value? K equals to 2 means k equals to 2. Okay, next left side, what is the formula here? Ri minus k minus 1. So here ri minus ri comma k minus 1. Okay, if you implement these values, r value, I value is 0, k value is k minus 1, k minus j value is k minus 1. So what is the k equals to 2. So 1 minus 1 equals to 1. So r of 0 comma 1 equals to 1. Again implement the same equation. Finally we are getting here r of 0 0 equals to 0. And what about here? R of 1 1 comma equals to k equals to 0. Okay, and this is the left side. And what about right side? rkj. Okay, what is the k value here? 2. Okay, what is the rj value here? 4. Okay, this is the I value, j value is the k value equals to 2. So same here. R of 2 comma 4 equals to k. Again k equals to 3. Okay, same procedure. Again I have to split according to this equation, these formulas, and we have to proceed up to we are getting the value, the every leaf node should be becomes the 0. Here k equals to 0, here also 0, here also 0, here also 0, here also 0. Okay, we have to expand the tree up to we will get all the root elements becomes the all the leaves becomes the 0. Now we get all the leaf nodes are 0, so we have to stop this binary tree here. We are branching here. Now we have to construct our final tree. Okay, according to this diagram, we have to only consider only k values. What is the k value here? 2. What is the k value here? 1. Here k value is 3. Here k value is 4. Okay, this is the diagram. This is the normal diagram. Okay, what we require is the normal diagram. See here. Here in this example, in this diagram, 2. Sorry, here 2. 2 is written. Next here 1. 1 is written. Here 3. 3 is written. 4. This 4 is written. It is normal diagram. And what about optimal binary search diagram? Means in the input values, in the given input values, we are taken. What is the input values we are taken? Elements are A, B, C, D. Okay. So what is the second element? B. First element is A. Third element is C. Fourth element is D. Okay. This is our final required optimal binary search tree diagram. Okay. This is the given input data. This is the our required optimal binary search tree diagram. Okay, thank you everyone. If you have any doubts in this topic, please refer our video one more time. If still you have any doubts, please ask me in comment section. Okay, thank you everyone. Hello everyone, welcome to my YouTube channel. In today's class, I will explain reliability design in dynamic programming in the subject of design and analysis of algorithms. Okay, welcome. Okay, coming to our topic, first of all, What is dynamic programming? A dynamic programming is nothing but the problem will be divided into number of subproblems. Each subproblem will be get their solution, and these subproblem solutions will be stored in future references. Okay, that is called dynamic programming. Here, what is meaning of reliability design? Okay, first of all, what is meaning of reliability? What is the meaning of reliability? Reliability is nothing but guarantee. Reliability is nothing but guarantee. Okay, genuinity. Okay, there is a in general Telugu terms, reliability means nammakam. Okay, the probability of working condition of a device is called reliability. Suppose if you purchase a device, if you purchase any device or any service, okay, what is the working condition? That is called reliability. The probability of working condition of a device is called reliability. Okay, design a system with high reliability with low cost. That is called reliability design. ఓకే, ఫర్ ఎగ్జాంపుల్ మీరు ఒక వస్తువు కొన్నారు, ఆ వస్తువు బాగా పనిచేయాలి, తక్కువ కాస్ట్లో ఉండాలి. అది సాధ్యమవుతుందా అండి? అలా సాధ్యమైతే దట్ ఈస్ కాల్డ్ రిలయబిలిటీ డిజైన్. ఓకే, ఫర్ ఎగ్జాంపుల్ హియర్ ఐఎమ్ టేకింగ్ device 1, device 2, device 3 up to n devices. Okay, here n is the n devices. Di is I greater than or equals to I, less than or equals to n. Okay, connected in a series. Okay, in this here if in this series connection, if one device does not work properly, then this entire system will be failure. Assume here D2 is not working properly. Okay, then what happened? Then D3, D up to n devices will not work properly. This is entire system will be failure. If one device does not work properly, then entire system will be failure. Okay, for example, if you connected like this in D1, in stage 1 we will arrange a D1 devices 3, and in stage 2 D2 devices are 4, in stage 3 D3 devices are 2. Okay, for example, I am taking a computer system. Here keyboards, for D1 stage I am arranged the keyboards, here D2 stage I am arranged the mouse, here I arranged the monitors, and up to and Dn stage I arranged the 5 CPUs. Assume. Okay, now at each stage we arranged multiple devices connected in a parallel system in each stage. Okay, let Ri be the reliability of Di. Let Ri be the Ri is the reliability of the Di. Then reliability of entire system is pi Ri. Okay, if you arrange like this, suppose in the stage 2 this device is not working, this device is failure. Okay, and stage 1 the first device is failure, and here D3 is failure. Assume. Okay, then what happened? Immediately the second device or third device will be work will be properly, and the process will be completed. There is no disturbance of the work. Okay, next let Ri be the reliability of the Di. Then reliability of the entire system is pi Ri. Okay, here what meaning of pi Ri means product of each device of Ri. Pi Ri is nothing but product of the each device of Ri. Let Mi is the number of copies of device I. Mi is nothing but is the number of copies of device. For example, M1 equals to 3, then we have 3 copies of the device 1. Okay, for example, M2 is 5, then how many copies we have? 5 copies. Okay, Mi is nothing but I is nothing but 3. So here 3 copies. Okay, M2 equals to 5, here I equals to 5, so 5 copies. Okay, next. Ri is the probability of device that work properly. Then R minus Ri is probability of the device which is not functioning properly. For example, ఇక్కడ ఏం లేదండి, Ri అనేది probability of device working properly అయితే 1 minus Ri is the probability of devices which is not working properly. Okay, these are the some points. Okay, next R 1 minus Ri whole power Mi is the stage I will not function properly with Mi devices. Then 1 minus Ri of whole power Mi ఈ స్టేజ్ I will function properly. ఇక్కడ function not function, ఇక్కడ function properly. Okay, overall cost of C is C1 plus C2, C1 comma C2 comma C3 up to n. Cost of each device is called I equals to C1 into Mi. The cost is one stage of I equals to C1 into Mi. Here what is CI? C is nothing but cost of each device. Mi is nothing but number of devices. Okay, in this one we have to remember these three formulas. What are the three formulas means? The total cost of entire system is stage 1 plus stage 2 plus up to stage ns is summation of Ci into Mi. The formula is summation of Ci into Mi. Okay, next, the reliability of all the stages are pi, that is pi 1 less than or equals to pi, sorry, 1 less than or equals to I less than or equals to n. Here pi of psi of psi I into Mi. Okay, pi I into Mi. Okay, next we have to calculate UI value. Here UI, what is the meaning of UI? Means upper bound value. Upper bound value or maximum number of copies that are allowed. Maximum number of copies that are allowed. Sir, why are we using maximum? Means to design the reliability, we have to arrange the maximum number of devices with less cost. So it is UI is nothing but upper bound another leదంటే maximum number of copies. Here for example, you are taking UI value equals to 3. UI value equals to 3. Then how many devices we have? I equals to 3 means D1, D2, D3, 3 copies. And what about fourth one? It is not allowed. Okay. How to calculate means UI equals to C plus the equation, the formula chudama, C plus Ci minus summation of j minus 1 to n Cj by Ci. Here what is meaning the j minus 1 means sum of C1 comma C2 comma C3. Summation on take C1 comma C2 comma C3. These are the important equations for the reliable design. Okay. Okay, the main objective of the reliability, the main objective of function is maximize the design. Maximize the design. Okay, pi 1 less than or equals to I less than or equals to n. Here pi I into Mi. Okay, that means what? To improve the reliability, to improve the reliability of the reliability to subject to, here we are taking Ci into Mi less than or equals to C. When this condition is true, then with given number of cost or budget maximize the reliability. Okay, next, if you will take one example here. Here we have three devices D1, D2, D3, and costs are the three devices are, the first device cost is 30, second device cost is 15, third device cost is 20. And first reliability of first device one R1 equals to 0.9, second one is 0.8, third one is 0.5. And what is the total capacity of the cost is, okay, the total capacity cost is 105. Okay, the C capacity is 105. Okay. Okay, next we need to find upper bound. We need to find upper bound. So what is the formula for upper bound value? Here UI equals to C plus Ci minus summation of Cj by Ci. So I am calculating here UI equals to, okay, U1 value. Okay, so that equals to C equals to 105 plus 30 minus here summation of Cj means all the values. So 30 plus 15 by 20. These are the C1, C2, C3 values. So by what is Ci value again? Ci value equals to, Ci is nothing but first value. Here we are calculating UI means 1 means, here also Ci means 1. Okay, that equals to 30. So what is the value? 70 by 30, that equals to 2.33. So we will round up means 2.32 items. Okay, here first device we can arrange 2 items. Okay, in first device we can arrange only 2 items. That means at stage 1 device when we can arrange, we can make maximum 2 copies. Okay, and what about U2 value? U2 equals to, what is our U2 value here? U2 ante emostama, U2 ante second device. Okay, U2 equals to, what is the formula? Same formula, 105 plus 15. 105 ante C, 15 ante emosthundi second device. So C2 ante Ci ante 2 kabatti ikkada Ci equals 2 kabatti 15 minus again same equation I am following. I am after calculation we will get 3 items. Okay, it means 3 items means at stage 2 device 2 we can make maximum 3 copies. And u3 కి వచ్చేసి 3 వస్తుంది. అంటే ఇక్కడ ఏమొస్తుంది, at stage 1 device 3 we can make 3 copies. Okay, here I represents, next not, next I power s power I j, s power I base j, that equals to I represents stage number. Here I represents stage number and j represents number of copies in the device. I represents the stage number of copies in the device. Okay, for example, s power cube base 5, it means what? Stage 3 maintaining 5 copies. Okay, stage 3 maintaining 5 copies. This is the just example I am telling. This type of values we will use in the next upcoming steps. So here it is the example. Okay, here implementing process, each one represented by tuple format, contains 2 parameters. 2 parameters are what? R comma C. What is the meaning of R ante reliability, C ante cost. C is nothing but cost. Okay, initially s power 0 equals to s power 0. ఇక్కడ ఏం చెప్పాను, I అంటే ఏంట? I is nothing but devices. Here s power 0 equals to what? S power 0 equals to no devices. S power 0 equals to no devices. So that equals to 1 comma 0. That equals to 1 comma 0. What is the meaning of 1 comma 0 means? 1 comma 0. So here mi equals to what? Number of copies. Mi equals to number of copies. So here in stage 1 in stage 1 we have to find out, this is the first no devices, 0th stage. Okay, here stage 1, s1 means what? At to stage 1 s1 equals to s1 power 1 base 1 union of s1 base 2. అంటే ఇక్కడ ఏమైంది, stage 1 contains how many devices? 2 devices కాబట్టి stage 1 output moves stage 2. So here s1 equals to m1, that equals to r. S1 equals to r. So what is the formula here? 1 minus r1 whole power m1, that equals to 1 minus r1 value equals to 0.9. Here reliability is 0.9 into m1 value equals to what? M1 value equals to 1. Okay, m1 equals to r value. So r value equals to 1. So 1, that equals to 0.9. That is the reliability. Okay, here stage 1, if you are maintaining only in stage 1, if you are maintaining only 1 copy, the device of the device, the 0.9 reliability. Okay, 0.9 reliability. In each and every stage we need to multiplying answer with previous stage. Okay, here 0.9 comma 30. What is the 30? Cost. Okay, that means 1 into 0.9 comma 0 plus 30 equals to 0.9 comma 30. And second stage 1 comma base 2, that equals to what? M1 equals to 2. So here first device ante మనకు 0.9 వస్తుంది and 2 devices ఉంటే 1 minus 0.9 whole square equals to 0.99. Here what is the tuple? The tuple is 0.99 comma C value is what? Here previously only one device కాబట్టి previously మనకు ఒక device కాబట్టి what is the cost of device? What is the cost of device is 30. Here we are considering 2 devices. 2 devices అంటే ఎంత వస్తుందమ్మా? 30 plus 30. So 30 plus 30 equals to, I am writing 60. Okay, single device is 30, 2 devices కాబట్టి 30 plus 30 is 60. So if you are calculating same formula here, 0.99 into 1 comma 60, that equals to 0.99 into 60. And what is the final value in final stage? In final s1 equals to 0.9 comma 30 comma అంటే ఒక సింగిల్ డివైస్ ఉంటే ఇది, 2 డివైస్ ఉంటే ఇది. ఓకే, అట్ వాట్ అబౌట్ స్టేజ్ 2? స్టేజ్ 2కి వచ్చేసరికి s స్క్వేర్ ఈక్వల్స్ టు, అంటే స్టేజ్ 2 ఈక్వల్స్ టు s స్క్వేర్ ఫస్ట్ డివైజ్, s అంటే s స్క్వేర్లో అంటే స్టేజ్ 2లో ఫస్ట్ డివైస్ ఉండాలి ఎస్ స్క్వేర్లో సెకండ్ డివైజ్, ఎస్ స్క్వేర్లో థర్డ్ డివైజ్. అంటే ఇక్కడ మనం ఏం చేయాలి, ఇండివిజువల్గా దీన్ని ఫైండ్ అవుట్ చేయాలి, దీన్ని ఫైండ్ అవుట్ చేయాలి, దీన్ని ఫైండ్ అవుట్ చేయాలి, తర్వాత మూడింటిని మెర్జ్ చేసుకుంటూ రావాలి, మూడింటిని యూనియన్ చేసుకుంటూ రావాలి. ఓకేనా. Here s square first one that equals to what is m2 value, m2 value equals to 1. అంటే ఏంటి, ఒక డివైజ్ కాబట్టి the formula is 1 minus r square whole power m that equals to 1 minus 0.8 whole power 1 that equals to 0.8. okay, what is the tuple value here? The tuple value is r comma c. okay, what r comma c, what is the r value here? R value is 0.8. what is the c value? What is the c value for second device? The second device c value is 15. okay, we'll see here. What is the r value is 0.8. okay, sorry, c value is 15, so 0.8 into 15. okay, again what I have to find out, the final value. yeah sorry, here I am finding s1, here I am finding s square base 1. so what is the base 1 value? 0.8 into 0.9 comma 15 plus 30 and 0.8 into 0.9 comma 15 plus 60. 15 plus 60. ఎందుకు? because of all the devices constructed in a serial fashion. so s1 s square base 1 equals to ఈ ఈక్వేషన్ పర్ఫార్మ్ చేసి వచ్చే వాల్యూ 0.72 comma 45. ఫైనల్ గా ఓకే, దిస్ ఇస్ ద s1 square value, s1 square value. and what about s2 square value equals to m2 equals to 2. సో ఇక్కడ ఏమొస్తుంది మనకి 1 minus of 1 minus 0.8 into whole square that equals to 0.98. so what is the r value here? 0.96. okay, what is the tuple value? 0.96 comma 30. so here what is, why you are taking 30 here, why you are taking 15 means here only one device, here two devices, so we are taking 15 plus 15 equals to 30. same equation we are performing in s square whole 4 s2 whole square equals to same this, like this is the tuple we are getting here. okay, and same like that we have to perform and third part also. s square 3 devices, m2 equals to 3 అంటే 3 devices ఉన్నాయి కాబట్టి ఇక్కడ కూడా మనము 15 tuple లో 15 into 15 plus 15 plus 15 equal to 45. so this is the 3 devices కి. సో మనం క్యాలిక్యులేట్ చేసి ఈ tuple వస్తుంది. ఓకే, మనం s2 అంటే ఏంటి? s1 s, what is meaning of s2? s2 is nothing but, s2 అంటే ఏందమ్మా ఇక్కడ? s2 is nothing but s2, sorry, s2 first device union s2 second device union s2 third device. so we have to merge all the three parts, we have to merge all the three parts. ఇక్కడ మనం ఏం చేయాలంటే, what is the maximum capacity? maximum capacity is 105. so here here this part only contains the 105. if we consider this, remaining will be not okay, not will be added, so we are removing this part. and what about this one? This one also 90. so it is also the reliability is high, cost is also high, so it is also not possible. and what about here? Here comparing remaining all, here the reliability is less and high price also high, so it is also not considering. and remaining, okay, see, and one more property consider, two pairs we don't have eliminate a tuple of less reliability with more cost. okay, so these three are the eliminated. and what about the remaining are 0.72 comma 45, 0.86 comma 60, 0.89 comma 75. these are the three. okay, these are the second phase, second stage. and what about similarly we are calculating the third stage. what is the third stage here? in third stage we have to calculate u3 equals to 3. so what is the third stage value? s3 equals to s3 first device union s3 two devices union s3 three devices. మా సేమ్ మెథడ్ మనం ప్రీవియస్గా ఎలా చేస్తాము, ఈ పార్ట్ ఫైండ్ అవుట్ చేస్తాము, తర్వాత ఈ పార్ట్ ఫైండ్ అవుట్ చేస్తాము, తర్వాత ఈ పార్ట్ ఫైండ్ అవుట్ చేస్తాము, మూడింటిని మిక్స్ చేస్తాము, మూడింటిని యూనియన్ ఆపరేషన్తో పర్ఫామ్ చేస్తాము. ఫైనల్గా మనకు వచ్చే యూనియన్ ఆపరేషన్తో పర్ఫామ్ చేస్తే ఇది వస్తుంది, ఇలా వస్తుంది మూడింటిని. సేమ్ మళ్ళీ మనకి మ్యాక్సిమం కాస్ట్ ఇది ఉంది కాబట్టి దీన్ని ఎలిమినేట్ చేస్తాము, ఇది కూడా దగ్గర ఎలిమినేట్ చేస్తాము. ఫైనల్గా మనకు వచ్చేది, ఫైనల్గా మనకి ఎంత వాల్యూ వస్తుందంటే 0.99 వస్తుంది. సో ఇది ద, సో స్టేజ్ 3 కంటైన్స్ 2 కాపీస్. స్టేజ్ 3 మనకు చేసేసరికి 2 కాపీస్ ఉంటుంది. ద కాస్ట్ ఆఫ్ 100 is remaining cost is stage 3 minus 2 copies. So 20 plus 20 equals to 40. So the remaining cost 100 minus 40 equals to 60. where you have to fill the 60. Where you have to fill the 60 means stage 2 also maintains 2 copies. That means 15 into 2 equals to 30. So 60 minus 30, 60లో మిగిలింది కాబట్టి అంటే స్టేజ్ 2లో మనకి 2 కాపీస్ పెడితే 20 ప్లస్ 20 40 అంటే 2 కాపీస్ సెట్ అవుతాయి. తర్వాత మిగిలిన బ్యాలెన్స్ ఎంత 105లో సారీ 100లో మనకి ఎంత మిగులుతుంది 60% కాబట్టి 60లో మన సెకండ్ డివైజ్లో కూడా మనము 2 కాపీస్ పెడితే 15 కాస్ట్ ఈస్ 15 కాబట్టి 15 into 2 ఈక్వల్స్ 30 కాబట్టి సో 60 minus 30 ఈక్వల్స్ 30. సో ఇక్కడ మనకి 30 మిగులుతుంది. సో వాట్ అబౌట్ స్టేజ్ 1? స్టేజ్ 1లో మనం ఓన్లీ ద కాస్ట్ ఈస్ 30 కాబట్టి ఓన్లీ బ్యాలెన్స్ 30 కాబట్టి ఓన్లీ ఒక కాపీని మాత్రమే అరేంజ్ చేయగలము. ఓకే, అకార్డింగ్ టు దిస్, బేస్డ్ ఆన్ దిస్ reliability, we can move the finally in stage 1 we can arrange only one device. In stage 2 how many devices? 2 copies, 2 devices. In stage 3 we have arranged 2 copies కాబట్టి 2 copies. Okay, this is about the reliability design. రిలయబిలిటీ డిజైన్ అంటే ఏం లేదండి, ఒక సీరియల్ గా సిస్టమ్స్ అన్ని కనెక్ట్ చేసినప్పుడు ఏదైనా ఒక సిస్టమ్ ట్రబుల్ ఇస్తే, ఏదైనా ఒక సిస్టమ్ ప్రాబ్లం అరైజ్ చేస్తే ఆ సిస్టమ్స్ ఫెయిల్యూర్ ని ఓవర్కమ్ చేస్తూ ఆయన సపోర్ట్ గా ఇంకో డిజైన్ ని ఇంకొక డివైస్ ని అరేంజ్ చేయడాన్ని రిలయబిలిటీ డిజైన్ అంటాము. మనకి ఇచ్చిన డిజైన్ ఎలా చేయాలంటే the design has to be built with more reliability with less cost. Okay, thank you everyone. If you have any doubts in this topic, please mention your doubts in comment section. If you like, please like our videos and subscribe our YouTube channel. Thank you everyone.